Yes, you are welcome to continuation of our discussions on topics in abstract algebra. Today we are going to continue with the B4 to see the other properties we can actually explore from that very special group. So I welcome you to illustration. Yes, you are welcome. We are going to continue, like I said, with our B4. Now, in our previous presentation, we discovered that if U is 1, 2, 3, 4, V is 1, 3, 2, 4, W is 1, 4, 2, 3, we actually found out that U square was equal to V square was equal to W square, which were identified as identity element. We are now going to continue to see what is UV. UV is going to be 1, 2, 3, 4 times another V times 1, 3, 4. So let us try to see the computations involving U times B. U is 1, 2, 3, 4. V is times V, which is 1, 3, 2, 4. So 1 is mapped onto 2 in the first cycle. 2 is fixed in the second cycle. 2 is also fixed in the third cycle, but 2 is mapped to 4 in the first cycle. So ultimately 1 is mapped onto 4. So we are going to have something like 1, 4. Okay. Okay, now where is 4 mapped onto? In the first cycle, 4 is fixed, but 4 is mapped onto 3 on second cycle. 4 to 3. 3 is mapped onto 1 in the third cycle. 3 to 1. And 1 is fixed in the fourth cycle. So ultimately 4 is mapped onto 1. So 4 is mapped onto 1, so I will close this. So 1 to 4, 4 to 1. Okay, what of 3? 3 is mapped onto, or let me even say 2, since I started with 1. What is 2? 2 is mapped onto 1 in the first cycle. 1 is fixed in the second cycle. 1 is mapped onto 3 in the third cycle, and 3 is fixed in the fourth cycle. So 2 ultimately is mapped onto 3. So I will now open another cycle and say 2 is mapped onto 3. Now where is 3 mapped onto now? 3 is fixed in the first cycle, but 3 is mapped onto 4 in the second cycle. So 3 to 4, 4 is fixed here, 4 to 4, but 4 is mapped onto 2 in the fourth cycle. So ultimately 3 is mapped onto 2. So 3 is mapped onto 2, so I will close this. So I have gotten 1, 4, 2, 3. But what is 1, 4, 2, 3? 1, 4, 2, 3 is W. So this gives me W. So this implies that U times B will give us W. Okay. I may also want to check what of VU, what of V, okay, or let me use the second, what of V times U? My V is 1, 3, 2, 4. And my U is 1, 2, 3, 4 times 1, 2, 3, 4. So let us see how the computation goes. Here 1 is mapped onto 3 in this first cycle. 3 is fixed here, so 3 is mapped onto itself. 3 is also fixed here, so 3 to 3 in the third cycle. but 3 is mapped onto 4 in the fourth cycle. So ultimately 1 is mapped onto 4. So I will write 1, 4. Now is 4 mapped onto 4 is mapped onto itself in the first cycle because 4 is fixed. But 4 is mapped onto 2 in the second cycle. So 4 to 2. And 2 is mapped onto 1 in the third cycle. So 2 to 1. But 1 is fixed here in the fourth cycle. So 1 to 1. So ultimately 4 maps 1. So 1 to 4, 4 to 1. So I will close this. This becomes a transposition now. Okay. Okay. What of 2? 2 is fixed in the first cycle. 2 is mapped onto 4, second cycle. 4 is fixed in the third cycle. But 4 is mapped onto 3 in the fourth. Sorry, 4 is mapped onto 3 in the third cycle. So 2 is mapped on 3. So I have 2 mapped onto 3. Now why is 3 mapped onto? In the first cycle, 3 is mapped onto 1. 1 is fixed in the second cycle. 1 is mapped onto 2 in the third cycle. And 2 is fixed in the fourth cycle. So ultimately 3 is mapped onto. So 3 is mapped back onto. So I'll have another transpose. So this gives me 1, 4, 2, 3. But what is 1, 4, 2, 3 here? 1, 4, 2, 3 is my W. So this gives me W. So this implies that VU will give me W. Okay. I may also want to check what of VW, V times W is going to be, B is 1, 3, 2, 4, and W is 1, 4, 2, 3. Okay. So my computation will be 1 is mapped onto 3, 3 is fixed here in second cycle, 3 is also fixed in the third cycle, but 3 is mapped onto 2, so ultimately 1 is mapped onto 2. So I'll have 1, 2. Good. Now I will pick 2. 2 is mapped onto itself in the first cycle because it's fixed. But 2 is mapped onto 4 in the second cycle, 2 to 4. 4 is mapped onto 1 in the third cycle, and 1 is fixed in the fourth cycle. So 2 is mapped onto 1. So I will close this. I have a transposition now. 1 is mapped onto 2, and 2 is mapped back onto 1. Now I will now open up another one. I will say what of 2? 2 is fixed here in the first cycle. 2 is mapped onto 4, second cycle. 4 is mapped onto 1 in the third cycle, and 1 is fixed in the fourth cycle. So 2 is mapped onto 1. Sorry, I am using 2 times. So I let him use 3 since I have 2 in the first one. Let me say 3 is mapped onto 1 in the first cycle. 1 is fixed in the second cycle, but 1 is mapped onto 4 in the third cycle, and 4 is fixed in the third cycle. So 3 is mapped onto 4. So I will have 3 mapped onto 4. Okay. Now why is 4 mapped onto? 4 is fixed in the first cycle. 4 is mapped onto 2, second cycle. 2 is fixed in the third cycle, but 2 is mapped onto 3 in the fourth cycle. So ultimately 4 is mapped onto 3. So I'll have another transposition. So I have 1, 2, 3, 4. But what is 1, 2, 3, 4? My 1, 2, 3, 4 is actually my U. So this implies that V times W gives me U. Okay. I may also want to know what is W. Okay. Maybe we'll stop here because of time. When we come back, we'll try to check other properties of this special group.